The Dynamic Learning Maps Alternate Assessment System is a new assessment designed to more validly measure what students with significant cognitive disabilities know and can do. This presentation is on calculating accurately with addition and will provide information to teachers of students with significant cognitive disabilities who will complete the alternate assessment. This training is one in a series of training videos that supports teachers in their efforts to teach and assess. Sponsored by a grant from the U.S. Department of Education, Office of Special Education Programs, this training is part of the professional development efforts of the Dynamic Learning Maps Alternate Assessment Consortium. Throughout the various math modules, we have discussed aspects that build knowledge for a student in the area of calculation. Modules such as unitizing, place value, 10 frames, units and operations, and composing, decomposing, and comparing numbers all have information that helps support the idea of calculating accurately when working with addition, subtraction, multiplication, and division. This module will specifically focus on addition, and there's a separate module for each of the other operations. Addition is essentially the act of combining any two or more numbers, whether those numbers are small or large. However, before students can do this, they must understand the concept of more and one more. And calculating accurately requires a number of skills and understandings. The first is the number relationships. This provides strategies that help students remember basic facts or ways to figure out unknown facts from those already known. There are three strategies associated with number relationships. First are the counting strategies. For example, with the problem 3 plus 5, the student starts with the 3 and counts on to 8. And later, after explicit instruction and experience, students may recognize it is more efficient to start from the greater of the add-ins, in this case 5, and then count on 6, 7, 8. Second are the reasoning strategies, using unknown information to determine known information. For example, 6 plus 5. The student knows that 5 plus 5 equals 10, and 6 plus 5 is 1 more, so it equals 11. Or for 3 plus 9, the student knows 9 plus 1 equals 10, plus 2 more is 12. The third strategy is mastery, knowing that 3 plus 3 equals 6, producing the answer fast and accurately without having to resort to figuring out the answer. In the past, we have typically taught students with significant cognitive disabilities one addition structure. A number plus a number equals an unknown. But there are actually several mathematical structures that students should have experience with in order to promote flexibility of thinking about numbers and amounts. And these structures actually help them learn the next skill and understanding, which is properties of operations. Concepts such as the commutative property, the associative property, and the identity property. We will elaborate further on these areas, but we'll only have a brief discussion on number relationships because more information can be found in other modules. Pause for Activity 1. Fact mastery refers to the automatic recall of any combination of quantities. This is usually all the facts, with the sums up to 20. This can be a difficult thing to master for students with significant cognitive disabilities due to the learning challenges they may experience. Challenge, such as a short attention span, being easily distracted, delays in language development, and difficulties with working memory. Still, other students may also have difficulty remembering information from one day to the next, or have difficulty generalizing information to other materials and settings. All of these contribute to the challenge of remembering math facts, and this is by no means an exhaustive list. It does, however, highlight the importance of students needing to experience multiple strategies dealing with number relationships that help them think through the problem. These strategies underlie number fact calculation, providing backup when direct memory falters for whatever reason. There are 7 identified strategies that all students tend to use as they are developing an understanding of basic math facts. 3 of them are presented here, and you will see the next 4 in a moment. One of the important things to understand about these strategies is that they are not hierarchical, but rather students use a mixture of structures to develop their understanding and fluency of basic facts, and teachers model and describe these strategies as they are working with students. For example, a student may use the strategy of counting all for add-ins larger than 6, with the teacher modeling shortcut summing. On other problems, the student may use finger display when the add-ins are less than 5. For other problems, the student may use counting on from the first add-in when the add-in is a 2 because he or she is confident in his or her number knowledge of 2. Sometimes the student may remember that counting on from a larger number is faster, and so they try that strategy. And the teacher then models and describes the linking strategy to demonstrate another way to solve the problem. After lots of experiences with all of these strategies, the student may be able to just recall that 3 plus 3 is 6. I want to reiterate here that just memorizing math facts through flashcards and timed tests is insufficient for all students, but especially students with significant cognitive disabilities who are very likely to have memory and retrieval issues. Focusing on number relationships is the key to teaching basic math facts effectively. There are a few other strategies that are good to know and use with students as they develop their calculation skills. The first is 1 more, 2 more. A quick example of an activity that utilizes this strategy involves the use of number cubes. The first number cube might have the numbers 1 through 6, or 3 through 8, like the left cube on your screen, or it could even have the numbers 5 through 10. The second cube has 3 sides with +1 and 3 sides with +2. After the student rolls the number cubes, they should say or indicate the fact represented on the cubes, in this case 9 plus 1. The Make 10 strategy includes all the combinations of numbers that add to 10, asking how many are needed to make 10. And as seen on your screen, using the 10 frame is a great tool for helping students to create a visual or tactual image of how many are needed. Finally, another powerful strategy for students to learn is the over 10 strategy. To start, students may use 10 frames to create the visual change between numbers, but eventually they may be able to do this in their heads. For instance, for the equation 7 plus 8, we want to change the frames so that one of them has 10. So in this example, we are moving 2 red dots to the 8 frame. So 7 plus 8 equals 10 plus 5, which is 15. Students can also apply what they have learned about place value when learning basic facts. For example, while adding 9 plus 7, teachers should encourage students to use the Make 10 strategy. 9 plus 1 plus 6 equals 10 plus 6. Here, students use place value reasoning to indicate 10 plus 6 equals 16. For further information on place value, please see the place value module. In problems such as 32 plus 43, teachers encourage students to add two-digit numbers by splitting each numeral into ones and tens, and then adding the ones together and tens together. See the example on your screen. 30 plus 2 plus 40 plus 3 equals 30 plus 40 plus 2 plus 3, which equals 70 plus 5, or 75. It's also very important that students gain experience with addition and regrouping. Let's look at a quick three-step example. 97 plus 35 equals. In step 1, the student adds the numbers in the ones column, so 7 plus 5, which equals 12 ones. Or we can regroup and have 1 10 and 2 ones. In step 2, we add the tens column, 9 plus 3, which is 12 tens. And when we regroup, we have 100 and 2 tens. Finally, in step 3, we add the three groups together, 100 plus 30 plus 2, which equals 132. Teachers should encourage students to add numbers in more than one way. Adding numbers using the hundreds chart or using Cuisenaire rods would be a great way to create a visual representation. In summary, here are some key points in helping students build understanding of math facts. Use problem-solving contexts that create a need for addition. Encourage students to use manipulatives or pictorial representations to model the action in the problems. Students should also communicate about what they have done and what they are thinking. And finally, teachers need to help students recognize when to move to more efficient strategies. We need to model, talk about and prompt memory recall of strategy by saying things like, is there another way you can find out how many? Or, what if you started with the larger number? Would you get the same answer? Pause for activity 2. Let's shift our thinking and look at the various problem structures that are used in addition. The structures help students identify important information and organize their thinking. They are also meant for you to use in your instructional planning so that students can learn to use addition in flexible ways, which will help them across the years as numbers get larger and additional concepts and skills are expected. The first structure is joining and adding problems. This structure refers to situations in which quantities are physically brought together. In join problems, you start with a quantity. Then an amount is added to that quantity, known as the change. And then you end up with the result. Any of these three quantities can be unknown in a given equation: the start, the change, or the result. For most students, the most difficult problem seems to be when the start is unknown. Let's look at some examples. Lori had 6 pennies. Pam gave her 2 more. How many pennies does Lori have altogether? This problem has real objects that can be manipulated. This type of problem can use present or past tense language such as put in, and, combine, dropped in, put with, and like the example on your screen, gave. In this problem, we start with the known amount. Lori has 6 pennies. Then we work with the change, Or how many are added to the known amount? Pam gave her 2 more. By physically adding these two groups together, we get the result, which is 8 pennies. Part-whole problems, or combined problems, involve the combination of 2 discrete sets, or splitting of one set into 2 discrete sets. This structure focuses on the idea that numbers are embedded in other numbers. Students can break apart 5 into 3 and 2, or 37 and 50 can be combined to make 87. So the problem structure possibilities are the whole is unknown, or the part or parts, if both the parts are the same size and value, are unknown. So for example, in the problem, Dreama has 6 coins. 4 of her coins are pennies, and the rest are nickels. How many nickels does Dreama have? The student can see the whole and knows one of the parts. When they use manipulatives, it's easier for them to find the solution. And just using the numbers increases the difficulty. So when you start teaching this concept, you might provide the manipulatives, and as students become more proficient, provide opportunities for students to use a combination of manipulatives and numbers, eventually providing only numbers. Compare problems involve the comparisons of 2 discrete sets of objects and identifying smaller or larger quantities, differences between quantities, or ratio relationships. Here again, there are 3 problem possibilities. The difference is unknown, the bigger quantity is unknown, or the smaller quantity is unknown. Many students will try to solve these problems using the part-whole structure by thinking the larger quantity is the whole and the smaller quantity is one of the parts. However, they need to recognize that comparison problems use 2 different wholes, and the quantities in part-whole come from the same whole. Take a look at this problem. Claire has 6 pennies. George has 4 more pennies than Claire. How many pennies does George have? In this problem, we know the smaller number, and we know the difference. When you combine them, you find the quantity of the bigger number. Pause for Activity 3. The final section of this module, on calculating accurately with addition, is on the properties of addition. Specifically, the commutative property, which is when you add 2 numbers in any order, you still get the same answer. The associative property, when you add 3 numbers, you can group them in any order and still get the same answer. And the identity property, when you add 0 to any number, you get the same number you started with. Again, this is not about sheer memorization of the definitions, but being able to describe what they are doing. In order to have students understand and not just memorize the properties, students need to be engaged with activities that prove the property. One strategy many teachers employ is relating the commutative property to the word commute. We commute back and forth to school. Some people commute to work. We commute to the school office and then come back to the classroom. Where else do we go in the school and then come back? Commuting is going back and forth. Then have the students work with a pan balance. On one side of the pan balance, place 3 pink cubes added to 5 black cubes to represent 3 plus 5. On the other side of the pan balance, place 5 black cubes added to 3 pink cubes to represent 5 plus 3. Then ask the students if the left side or the right side has more. They should see that the two sides have the same amount. Write out 3 plus 5 equals 5 plus 3. Repeat the process with multiple addition problems, continuing to refer to the idea that the commutative property means going back and forth. Giving students time and experience to draw the conclusion that it doesn't matter the order in which you add numbers, you will still get the same amount. Another activity to help students understand the commutative property is called Flip the Domino. The students write or indicate the quantity on each side of the domino and then find the sum. Then a student or teacher flips the domino so the amounts are reversed, and again the students write or indicate the quantity on each side of the domino and find the sum. Do this with several dominoes, being sure to model the think aloud. When you add two numbers in any order, you get the same answer. Addition can go back and forth. After several examples, ask the students, does it change the total amount of the domino when we flip it? Can we start the addition problem with either number? Why do we get the same amount? Remember that students need to use a lot of different materials and have multiple experiences in order to see that the property works all the time, not just when the teacher says it will. The associative property is a lot like the commutative property. It's still about being able to add numbers in any order, but using more numbers makes it harder to know where to start. So the parentheses tell us where to start. So when you begin teaching this concept, discuss the base word of associative or associate. Explain that associate means to put things together or to group them. Show them an equation with parentheses and talk about how the parentheses group numbers together and tell you to add them first. Again, use the pan balance and unifix cubes to model how the associative property works. On the left side of the balance, place 3 pink cubes on top of 2 green cubes next to 5 black cubes. On the right side, place 3 pink cubes next to 2 green cubes on top of 5 black cubes. This represents the equation 3 plus 2 plus 5 equals 3 plus 2 plus 5. Ask the students which side has more. They should agree that both sides are the same and draw their own conclusions that it doesn't matter how you group numbers together in an addition equation, the answer will still be the same. The identity property means zero change to the number. To model this property, place 5 black cubes on the left side of the pan balance. Then demonstrate adding 0 more. Use your hands to show that you are not adding any more. Ask them which number should go on the right side of the pan balance to make both sides of the equation the same. Let them explore different numbers until the balance is even. They will find 5 black cubes are needed, since the number didn't change. They should draw the conclusion that any time you add 0 to a number, the number stays the same. So remember that the keys to calculating accurately with addition are understanding number relationships, understanding the structure of problems, and understanding properties of addition. Thank you for participating in today's module. For more information, please go to www.dynamiclearningmaps.org.